Hey, feeling good, like I should. When in dark, walk around the neighborhood. Feeling blessed.
Alrighty, so for today's homework, starting with the M&Ms for the mean, whenever we talk about an average, people are almost always referring to the mean, although the average could also be used for median and for the mode of the data. The mean is most commonly used. I use it when I'm figuring out your grades. You know, your average grades are always your mean. And the mean grade or the mean average is generally used when your data does not contain outliers. We'll get into this a little bit more a little bit later in the year. Maybe this chapter, maybe chapter 2 or 3. I can't remember when we get into the averages. Or actually, maybe it might be when we get into data and statistics closer to chapter 8. I can't remember. At any rate, mean. How do you find the mean? Well, that's the process where you take each one of your individual pieces of data, numerical data. You can't find the mean if you don't have numerical data. And then you add all of them together and divide by the number of numbers. So the mean is supposed to be a number that is toward the middle, toward the center of your data. That's why they call it measures of central tendency, because you're trying to come up with a number that best describes this set of data. For instance, what does this say? Suppose the following data represents the number of home runs hit by the best 7 players on a Major League Baseball team during one season. Well, those are horrible home run outputs for Major League Baseball. But at any rate, let's pretend this is like 1908 or something and they hardly ever hit any home runs. What one number would best describe the number of home runs hit by these players? Well, you could put them in order from least to greatest, say 9, then another 9, and then what do we have? 13, then 15, then we've got 16, then what do I have? 9, 9, 13, 15, 16, then 21 and 26. So the number that falls in the middle there, this number would be the median. This is the process that I just showed you for finding the median. But the median and the mean should be relatively close to each other if there are no outliers. And so what number comes closest to the center of this data? Well, as far as the mean is concerned, that would be 15.57, which you may choose to round up to 16. But you can see there how the 15 fits right square in the middle of the data. All right, so let's play a guess my number. 2 wants to guess my number. She states, when I triple my number, okay, so I'm going to triple my number. Here's my imaginary number. I don't know what it is yet, but we're going to figure it out. 3 times the number, then add 5, you will get 26. Okay, so let's take a look at this. What number do you add to 5 to give you 26 for an answer? That number has to be 21, right? So 3x's must be equal to 21. And what do you multiply times 3 to give you 21 for an answer? That's 7. So her number must be 7. So we can always check that and say, all right, so I'm going to take my number and I'm going to triple it and I'm going to get 21. Then when I add 6, then when I add 5, I get 26. And that's what we're supposed to get. Yes, that works, even though my 5 is very sloppy. Okay, so that proves that the answer we got was correct. All right, so let's find the mean for all of these numbers. Now, the mean, it's not a lot of fun. I almost think they call it the mean because it's cruel to make students add all these numbers together and then divide by the number of numbers. However, I allow students to use their calculator. So we take 82 plus 64 plus 73 plus 91 plus 85. We get 395. So is 395 divided by 5 going to be equal to 79? I think it is. Yes, it is. So here I partially used my calculator. We could have just gone divided by 5 and gotten the answer like that. Now remember, the calculator is a tool to be used when we're problem solving. And I consider finding the mean to be problem solving. If I'm asking you how to multiply 2 numbers together, You're not allowed to use your calculator for that. You need to know how to multiply. If I ask you how to add two integers together, you're not allowed to use your calculator. I want to know if you can add positives and negatives together. But when we're just problem solving and the goal is not to find out if you can multiply two numbers together, then go ahead and use the calculator as a tool to help you solve the problem. Okay, so I'm not going to work through the rest of them. You just should know that you have to add these numbers together and divide by the number of numbers, even if one of the numbers is 0. That's one of the numbers in the set of the data. So you have to add the 0 to the 1 to the 3 to the 2 to get 6. And then there were 4 numbers that you added together, even though one of them was a 0. So that has to be a part of your division process. All right, Julio's architect is an architect who designs skyscrapers. Assume that each story is 15 feet tall. So how tall would a 2-story building be? That would be 30 feet. 10 stories would be 15 times 10. And then 30 stories would be 30 times 15, which is 450. Now, if you want to go in reverse, if this building that was designed was 750 feet tall, and you know that each story is 15 feet, how many 15-foot stories can you get in a 750-foot tall building? That's the question that we always ask whenever we're doing division. How many of these can you fit into there? So how many 15s fit into 7? 0. How many 15s fit into 75? 5 of them, and that would be 75. And now you got your remainder of 0, correct? Except for one thing, you still got another digit here. We need to keep working until we get to that decimal point. And if you don't see a decimal point here, just know that it's always to the right of the number and put it in to your division algorithm. And then 15 goes into 0 times. Now, 0 matters, but this one doesn't. And so our answer is going to be 50. And of course, if you take me up on my offer to allow you to use your calculator, you would see the answer is 50 as well. All right, which is greater, 3/4 or 11/16? How can you be sure? Well, here's a process where it's hard to compare these two fractions without having the exact same denominator. Once you change these so they have the same denominator, and I think the denominator should be 16, right? Because 4 goes into 16 4 times. And I can multiply the numerator and the denominator of 3/4 times 4. And this is what we call a giant 1. So we're multiplying 3/4 times 1. So our resulting fraction of 12/16 is equivalent to the original 3/4. It's just written as a different ratio. So now we're going to compare 12/16 to 11/16, and now that we see that they have the same denominator, all we have to do is compare the numerator, and 12 is greater than 11, so 3/4 is greater than 11/16. And I believe this is the last problem. Yes, the last problem. So finding the perimeter and the area of each one of these shapes. This one, the area is pretty easy. You're just going to count up 1, 2, 3, 4, 5, 6, 7, 8, 9 square units. As far as the perimeter goes, just count your way around. You will count 18 units. Here, remembering if this is 5, this has to be 5. If that's 7, this has to be 7. So 10 and 14 make 24 for the perimeter. And then base times height, since the 4-foot height is perpendicular to the 7-foot base, we'll multiply 4 times 7 to get 28. And here, same idea, this is a 15 and this is an 8, so you get 30 and 16 is 46 for the perimeter. And 18 times 15 is 120. Now, one other thing we have to make sure that we get correct. When we're finding perimeter, our units of measurement are always linear, which means you're just going to write the unit of measurement. Here are their units, here are their feet, here are their centimeters. But when we're finding area, our units of measurement are in squares. How many squares fill up the space? So that's where we have to include the square units, the square feet, and the square centimeters. And if you don't remember where to put that exponent of 2, you could always write this as 120 square centimeters. There's nothing wrong with writing it this way, just like I wrote it here. So if you're ever in doubt where to put that exponent, don't the exponent and write it this way instead. Just use words. Okay? All right, how much time did that take? Yay, we're getting 10 minutes. All right, good job. Hope you made all your corrections. If you haven't, go ahead and clean them up right now, and I'll talk to you tomorrow. Bye.
Hey, feeling good, like I should. When in